Okay, welcome back to part 2 of my tutorial on how to make a node. So in part 1 we created the H file for everything you need to do a Gaussian blur node. So here is the file. So let's start by including what we'll need. So we'll need to include OpenCV first, and in OpenCV we need the core stuff first and foremost. So let's include opencv2/core.hpp, and then because we know that Gaussian blur is in, where is Gaussian blur in? It's in image processing. Let's go back to Gaussian blur. Here it is. So let's include image processing as well. And then if we need anything else, we'll include whatever else we need as we go. Okay. So with our OpenCV includes in, that should be everything we need. Everything else is in our H file that we might use. So for the constructor, first what we need to do is we need to instantiate our window. New widget. The parent constructs this. We just need to instantiate it as a new Q widget, and what the window does is it will hold. It's a widget that holds everything else, and the way it does that is it holds the layout, which that holds everything else. So next we need to instantiate our layout that we've created. New Q grid layout, and this is our layout. Next, let's do all of the widgets. So for our widgets, we have side by side this. To start with, we have our progress bar. So let's do that. Equals new Q label active. So our progress bar is inactive right now. It's not an actual progress bar, it's just text, but it'll show us what's happening in my threaded. Next is the labels for the size X and the size Y. Let's create these. Label equals do that. Size Y label will instantiate that as vertical blur. Comment this. Instantiate widgets. Next we have our actual line edits. So size X input equals new line edit, and we'll do the same with size Y. Okay, so these are all of our widgets that we need to instantiate. Next is our validator. So we created an odd int validator. Just need to do equals new Q reg X validator, and I just copy in one that I found online. Here, and all this does is it makes sure that we have whole numbers that's 1, 3, 5, 7, or 9, and this is where we parent it to, and we'll just parent it to this node itself. We don't need it anywhere else. And then we can set our inputs to have the validator of odd int. validator. On same for y. There. Okay, so now that we have our input validation set line now that we have our input validation, let's add everything to our layout. So add widgets layout. Okay, so we have layout, add widget, and we have 5 widgets. Let's just do this 5 times. First is progress bar. We'll set this as 2, 0. This is the that's the row, and then the column here. Next, we'll do size x label at 0, 0. We'll add in the size y label at 1, 0. Size x input 0, 1. Oops. Size y input 1, 1. There. Okay, so everything's added to the layout now. We just need to add the layout to the window by using window set layout layout. There we go. Add layout to node window. Okay, so that's all of our UI set up. Now we can start connecting stuff from all of our slots to the signals. Actually, before that, size y set text. Let's start by setting the text to 1 for our size y and size x inputs. Because we've initialized them as 1 here, and we want them to default to 1 just in case the user just creates a node and then plugs it in and has it go. There's already something that there, so it won't crash, and it basically doesn't do anything if it's a 1. So that okay, so next we will actually connect everything. So to do that, we use the connect function. And first is our function watcher. So let's connect the function watcher function. Function watcher, a signal, and check what signals this actually has. And we can find that it has, under here, it has these signals, and we want finished. We want to connect it to our multi-threaded finish function. So let's take that, finished, and we'll connect it to this slot multi. Copy that. Here it is. This signal. Okay. Next, we want to connect our inputs to set sizes, this function, whenever they've been changed, so that we can dynamically update everything that we need to for our kernel. So we'll just connect Size X input, we'll do signal, and oops, signals they have. So our size X and size Y are a 2-line edit. So their signals are here. So we have text change, text edited. I think the difference between these two is text change checks for any changes with the text, and text edited just checks if the user changed the text. So we can use text change just to be safe and send this as a signal. And we don't need this. Use QString to demonstrate the parameter, but we don't actually need it to do anything, so we'll just leave it there. This slot set sizes. Okay. Then we'll do the same thing for Y. There we go. That's all of the stuff that we want connected done. Close this. What's next? Next we have our context window. We need to build context window. This is called the build context window function. Builds context window. And this will be in a parent class. We need to instantiate our image out. Our out data needs to be created here so that we can make sure that it always exists, where image in would have gotten created in the previous node, so we don't have to worry about that. So init outgoing data image out equals there we go. Okay, so that rounds out our constructor. Next, let's do the ports. Start with imports. Oh, that's okay. So the port type sent to us, we can a switch statement to tell whether it's in or out, and then return the number of ports that we have. Switch port type case in turn 1 case type out turn 1 turn here. No, there's only one port, both in or out. You can actually just get rid of this entire thing. Just return to 1. Next, let's do the data type. Node data type. Data type. Okay. So for data type, we have the port type and the port index. So we can do a nested switch statement or a nested if statement. Whatever you want. Copy this and since we know there's only one, will always be one. We can just return for both of them image data dot type. And this for everything. Okay. So we'll just always return image data dot type. So we don't really need this. But if you have a different input output data type, you can specify whatever you return here. Next, shared pointer node data Gaussian blur out data for index. This specifies where our out data is and just this, so we can just return that. And if you needed to, if you need to change the port index, you could just do a switch statement and return a different one for each port index that you have, depending on how many port indexes you have. But since we just have one, we can just return image out. Next is the set in data function. Set in data. Oh, whoops. Set in data. There we go. And here we can take our input data and try to save it as a image in. And since it's shared pointer, we can do equals std dynamic pointer cast, which will be safe in trying to cast our node data into a image in, because if it doesn't happen, it'll just save this as nothing. If it doesn't work, it'll just save it as nothing. So we can try this. Data node data. It's basically like a try catch inside of a function. And if you can just check to make sure if it has been added by checking if it exists. If it has, we can validation state as node validation state valid, and this will tell us that we are ready to do work, in the sense that the input data is ready. Error. Okay, and then we can call pre-check from here. And even though pre-check is a slot, we can just call it regular without needing to rely on the connect. And then if it's not, if this fails, we can just return this to a warning. And qstring doesn't matter. Doesn't matter too much. Okay, next we have this. We can just do node validation state blur validation state. All this does is it returns this, and this returns this, so we can just call it to return that string. model validation error. Okay, that's all of our validation stuff. Now we can go into our process data function. Make some room. Okay, so void Gaussian blur process data. So because we don't want this to happen on the main thread because it could cause too much of a lag, we want to use our multi-threaded process. So in here, all we'll do is we'll call the multi-threaded process function to run using future, and then we'll set the future watcher to watch it so that we know when it's done. And then it will automatically call multi-threaded finished. So process bar, progress bar, set text. We can update the progress bar to make sure the user knows what's going on. And funct this multi-threaded process. There we go. Okay, so this is all this is doing is it runs the multi-threaded process function in a separate thread. Funct watcher dot set future funct. Okay. And that's all we need for processing data, because we're not actually doing any processing. We just want to start the multi-threaded processing function. Next is our pre-check function. Let's do that. Void check. So what we need to check a couple things. First, we need to check if the input data has been created. So image in. This will tell us if it's null or not, and if it does exist, we want to check if it's ready. This will be dependent on previous node finishing all of its work. Once it finishes all of its work, it will switch its data to be ready, and then when we receive that data, we know that it's ready, so we can process it. Otherwise, we might get faulty or outdated data that we don't want to process. So next is active. This just checks if this current node is active to be currently functioning, and the way you turn that on and off is just by activating it or deactivating it. Auto validation state equals. So if it is, if everything is good, we do node validation state valid. We say that the validation state is valid, and error nothing, just to make sure that it's good, and process our data. Calling process data. Else we will do warning and if count is unready. Okay, and if we know that our pre-check failed, we can set the warning to be on and our out data to be unready so that the next node following this knows that it's not supposed to start functioning because our data is bad. Okay, so pre-check. After that, we have our show context menu, and all that is just a copy paste that we need to do to set up the context menu, so we can just go to any other CBB file, road image, copy that over, replace that with Gaussian blur. Okay, close that. Next is our set sizes function. So this is for setting these sizes based on our widgets using the connection function. So Gaussian blur set sizes. Okay, so we'll just make it so that both of them, if you trigger either of them, both of them updates, make it easier. So if font size input text is empty, if it's not empty, we will do size x equals size x input text 2 size input of text dot int. There we go. So this will just set the size x as the int of size x input, and because we have a validator on it, we know that it has to be able to turn into an int, and it has to be an odd number that's positive through our regular expression validator. We don't have to do any additional checks here, and we'll do the same for y. There we go. Once this is done, we'll just call pre-check again, because we've updated our data at this point. So next is our actual multi-threaded process and multi-threaded finish. So let's do that. Void Gaussian blur multi-threaded process. Okay, so for this, we need to use the CV Gaussian blur function. So it's the function here. It has an input, an output, and a size kernel, as well as sigma x and sigma y. These are basically just for standard deviation, and we don't need that, so we'll just leave those as 0. And the border type is border default, which we'll keep it as. So before we do that, let's create a version of our mat temp. Let's make a version of our image so that we're not affecting the output of a previous node. We don't want to ever change our input. We'll always want to change our output. So let's just create a temp equals in. This will set pass by copy a reference, a version of this image into our CV map temp. We can use that as our CV Gaussian blur temp. So it's both our input and our output. We'll take it as input and then we'll output into it as well. CV size, and then our kernel size x size y, then 0 0. Okay, so this function will do the actual Gaussian blur. Next, we'll have our image out, image temp. So we'll pass by reference this image into this image in our image out data, and then this will get cleaned up. Void blur. Next is our multi-threaded finished, which in here we will use to say that our image out is ready. Ready. We'll do progress bar, set text, finished, to show that our operation is successfully finished, and then we will emit data updated. Oops. Up. There. And this will, whoops, we gotta put the index of the data, which is 0. This will show that our data is ready and needs to get updated again. And the next, whatever the next node is, we'll call set in data once again. So now that we have multi-threaded finished, we can do our final two functions, our save and restore functions. JSON. Save. So what save does is it gives us a method of saving stuff outside of just node name itself. So we can take all of the data that we have extra that we want to be able to save, and set up a parser here to parse it out and into from a JSON object. And basically that's just the size X and size Y that we have. So let's do QJSON object, data JSON, and create one of those, data JSON. So first we need the name, and that goes with every node. So let's add the name equals name. Let's use our own name function here. Next is the size X and the size Y that we want to save. So let's copy this. Size X equals size X, and data JSON size Y equals size Y. There we go. Okay, so we have our size X and size Y on our name. Now we just need to return it. And this will override the default save, which is just the name. And since we've overridden the default one, we need to override our default load as well. Otherwise, these will just not get used. Restore. So, for our restore, we have JSON. We have our JSON object that we get back. Just check first if JSON, just to be safe, contains size X, needs to be capital, and actually we can just set them as the widgets themselves, because the widgets would have already been created by now. Because before the JSON gets created, it calls the constructor. So we can do size X input, that text, JSON size X dot to and we'll do the same for y. This will just check if it contains it and save it to our widget if it does. And since we know that this will get called automatically when we change the text, we can rely on whenever we set the text, set sizes will be called, and it will automatically update what our local variables need to be. So once they're done, it will automatically call set sizes, and it will automatically call pre-check after that. So usually we need to call pre-check after our restore just to make sure that the system will auto run if you load it to be able to auto run. But in this case, we don't need to, because we would have already called it. Okay, so that's it. I think that's all the functions that we have. So this now should work. Now that we're done the function, the class, we can add it into our filter node, which is where we have all of our other nodes. First, we'll just include it in the CPP node editor / Gaussian blur, and then we go down here to Gaussian blur will be editing. We go to the editing category and just type in final register model Gaussian blur. We need to put it in editing, and now it should be in the menu of nodes that we can call upon. So let's see if it works. And filter node, what it is it's just a class that creates an instance of all of the nodes and allows you to create new instances of them from a context menu that you can create from right-clicking on the node graph. Oh, we have 5 errors. Undefined reference to Gaussian. What's wrong here? Have undefined reference to Gaussian blur. Oh, we don't want this. We don't want to actually create this. There we go. And it's starting. Here it is. Put a new test, and we'll do. Here it is, our Gaussian blur node. Here we can define the horizontal blur. Let's do, and it has to be an odd number. So let's do 99. We'll do 15 here. Do a let's do a video source. We'll do a frame iterator to create some frames. We'll do page display. Okay, so here's a video. Go into downloads. Ooh, this will take a while. Not a small video. Not the smallest that I could have picked. Let's go to frame 40. And we'll wait for it to do its thing. Okay, there we go. Go to frame 40 and see it did it, and let's hope this works. And it's good. So it's looks like it's being blurred by 99 on the horizontal, and let's do the opposite. Let's do 25 and 99 here. Seems like it worked. Okay. Thank you for watching the tutorial. Let me know if you have any questions in the comments. I'll try to get to them as I see them.